Okay, today is November the 21st, 2024. I'm going to take you inside my stash here with transformers and stuff. Yes, I know I'm going to be moving around a lot, but that's just the way it is. And I'm going to show you, we're going to build an amplifier. The other day, on my last post, I asked what kind of an audio project would you guys like to see, and I got 2 responses already. So what we're going to build is an 807 SC amplifier. How's that sound? A lot of these are power transformers. Down here, big guys, little guys, whatever, modulation transformers. I got some magnificent audio transformers, and I don't know if I'll ever build with them or not. They actually belong to my friend back in Florida. These UTC guys right here. These things are probably worth, a pair of these things probably worth $3,000. Here's an LS63. Here's 2 more down here. Right there and right there. That was getting built into an amplifier. Here's another big UTC transformer. Here's even the specs are 2,500 ohms. I think it's made for like parallel push-pull 6L6s or whatever. But that's not what we're going to use. What we're going to pick out here, I've already set aside over here, are these transformers right here. These are custom wound transformers from a friend of mine in Poland. I bought them a few years ago. These are the bigger ones. I don't remember their exact ratings. And here are 2 smaller ones. Of course, we're going to use the bigger ones. And here are chokes. See, unloaded, it measures 72 henries. And loaded with 100 milliamps at 16.4 henries, which is still quite a lot. I will go into every possible detail I know and think I know about the selection of these things. We're gonna measure these, and we're gonna know what the primary impedance is with an 8 ohm load, and maybe a 4 and a 16. We don't want to belabor it too much, but I'll show you how I do this, and it actually lets us know what the real impedance the tube is going to see is going to be. Okay, so we need one of these. I'm going to build one channel. I'm not going to build stereo. I already got too many amplifiers. Just have too many. Okay, so now we need a power transformer. I always use chokes. Here's a bunch of chokes down here. Small, kind of keep things lined up. Probably something like this, 1.5 Henry, 500 milliamps. I like one with plenty of current. We're not going to be drawing anything like 500 milliamps. Anyway, we got to look through these things. There's 300 milliamps, there's 1 Henry. I'll show you how you determine what kind of inductance level you need. Before we get into all the detail, basically, you know how resistance is R equals E over I? Well, it's kind of a hack, and I don't like that word hack. But basically L, the minimum amount of inductance L in henries is basically equal to E, the voltage, over I in milliamps. Not in amperes. Volt in volts and current in milliamps. So if you've got, say, 500 volts and you're drawing 100 milliamps, you divide 500 by 100 and you get 5. So you need like a 5 Henry choke. This is real. It actually works. It's not like pure science, but it works quite well. These are all chokes, so we need a power transformer. Nothing like these monstrosities. I'm not exactly sure which one I'll select down here. I'll have to think. Something in the proper range. Maybe even something like this. This looks like a brand new one. 100 milliamps. Yeah. How much voltage? 325 volts each side. Well, that sounds just about perfect, doesn't it? Be like 32 watts. I believe that's it. For a single in at 807. Well, I hadn't actually thought about that before pointing the camera at it, but that might be a good idea. I guess it's got 6-volt windings on it too. Yeah, it does. Wow, that was perfect. Even a 5-volt 3 amp. Wow, we can even use a 5U4 on that guy. Yeah, we'll have to use vacuum tube rectifiers. Here's some more transformers. Yeah, I don't want to use these little tiny single-ended transformers. Or these, I made some videos some time ago about these matching transformers. But I don't think they are rated for any kind of current flowing in the primary. So we're not going to use them for SE. These are modulation transformers and what have you up here. And some stuff for the kitty cats around here, of course. Okay, so this is the beginning. We'll use a new chassis instead of some of these monstrosities over here. And we'll be taking these home, or at least one of them, and building something with it. So I'll be right back. Okay, we're at the workbench now, and we're going to measure the smaller of the two transformers. Here's the small one, and here's the larger one. We'll measure them both. And I'm going to try to work with smaller stuff. I just have a tendency to want to go over the edge. You know, I want everything to be 1,000 watts. This floor squeaks, so if it sounds like a cat meowing, it's my squeaky floor. Okay, look. I got this really nice little LCR tester. I recommend this guy. MS5308 LCR tester. Okay, we're going to measure the inductance. That's going to tell us a lot. Now, to measure inductance, you have to have all of the windings open. Don't short anything to anything. If you short one side or the other, like if I short this side and then measure this side, what I'll end up getting is what's called a leakage inductance. We don't want to know that. We don't care about that. Nothing we can do about it. So what we're going to do is measure the inductance of, this is the primary first. We just hook up our little LCR meter and let it do its magic. Okay, with the secondary open, and there it is, 22.74 H for henries, 22.74 henries. So we're going to write that down, 22.74 henries. Okay, now we're going to take it off and we're going to measure the inductance of the secondary, the part that would hook to the speakers. This is the secondary. And it says it is 40.35 mH millihenries. So it's very low. We call it 40.4 millihenries. 40.4 millihenries. Okay, now the impedance ratio and the inductance ratio is the same. It's the same ratio. So all we got to do is divide this. Okay, so we're going to take our little magic calculator, 22.74, and divide it by 40.4, 40.4 E3, change sign, divide, because we take millihenries. And that's our impedance, that's our inductance ratio, and it's also our impedance ratio, 562.87. 562.87. Okay, equals 62.87. Now what that tells us is, for example, if we put 8 ohms out here on the secondary, I think everybody knows that the primary impedance is a reflection of the secondary impedance. If we put 8 ohms here, all we got to do is multiply this times 8, because our inductance ratio and our impedance ratio are the same ratio. So we take the 562.87 and we're going to use an 8 ohm load. We put in 8, multiply. We got a 4,502.97. 4,500 ohms. I think that's just dandy. Don't you think? 4,500. About 4,500 ohms. I'm impressed. Very, very happy with that. Well, these are custom wound transformers, so you would expect that. The man knows what he's doing. Okay? So that's the little guy. Let's do the big one just while we're at it. We've got to do the same thing. Nothing shorted. and we'll measure its primary impedance, or not impedance, but inductance, and it happens to be, I think you can see that, yeah, 48.6 divided by the other side. And remember, we're measuring the inductance now. All the windings are open. And here's the other side. And it is 74.9 millihenries. 74.9 millihenries. Now if we do that ratio, 74.9, or, well, that's millihenry, yeah, 48.6 henries on one side, and 74.9 E3 change sign divide on the other side. 648.87 equals 648.87, and then we multiply that times 8, because we're going to use an 8 ohm load. 8 times, we get 5,190. Basically the same. I mean, they're close enough that if you wanted a 5,000 ohm transformer, they'll both work great. 5190, but we'll write that down. 5190 ohms. That's the way it works. Now, let's just keep rolling here for a minute. I'm going to get an 8 ohm resistor. Now we're going to measure. We don't have to do that. Yeah, let's verify it. The way that we can verify this, we're not going to get exactly the same number, but we're going to get something close. What we're going to do and it's a good thing to measure things more than once. What we're going to do now is we've decided that this transformer right here, this little beauty, we've decided from our measurements and our calculations that if we put 8 ohms on this side right here, we should measure an impedance of 5,000 ohms on this side. Let's see if that's what we get. Stop the camera and I'll hook it up. Be right back. Okay, now I don't want you to miss anything here. I hope I can make a good connection here, because good connections are very important. It's amazing that even at microamperes, good connections are very, very important. I found that out a long time ago working at White Sands with little tiny micro switches, like in the, you could measure with a DC ohmmeter. You say, well, there's nothing wrong with a switch, but just the tiniest bit of DC resistance in there. Okay, we got 8 ohms on that side. Now, what do we expect? We expect about 5,000 ohms. And let's see what we get here. Let's see now. We've got to put this thing, we've got to measure it properly. That's not the right way to do it. We don't want, yeah, we do. We want RS. That's actually the right number. See, this way it says we got 6,300 ohms. 6,300 ohms. So you see, you're not going to get the same numbers every time. I'm not trying to make this vague. It's just that if you think you're going to, you know, I've used this analogy before. This is not a bank account where you have $100.02 and you write a check for $100.03 and it bounces. It's just, you're never going to get that close. This is a different type of measurement, and you're going to get something different, but you are going to get something in the ballpark. Now this is measured at 1 kilohertz. Let's see what happens if we measure it at different frequencies. I just want to show you that this is actually real. This is 10 kilohertz. Now that went back to LS. We went back to we don't want inductance. That's capacitance. Holy mackerel! Yeah, we do want RS. We're back at 120 hertz now. Let's see. Let's change the function right here so we can go back to CS, RS. See, now if we measured it at 120 hertz, it's a little bit different. It's 6,000 ohms, 5,999 instead of 6,300. This is real, and this is okay. And you have to expect this. There you go, exactly 6,000 ohms. Now, by the way, I want to mention something here. RS is called series resistance and is exactly the same thing as ESR. You know, when ESR meters came out a few years ago, it was like they invented something new. Well, they didn't. It's just in the old days they called it R with a little subscript S. Series resistance. And what series resistance is resistance for AC, for an AC signal. When I say AC, I don't necessarily mean wall frequency, 60 hertz or 50 hertz, depending on where you live. I'm talking about a signal level of a kilohertz or whatever you want to measure it at. Okay? I'm trying to show you things that aren't going to tell you that well, life isn't perfect. Life is an estimate. I like that term. Everything in life is an estimate. I even like to joke, this life is only a test. If it were real life, the government would have issued you a instruction manual. Well, we thought that one was funny. Okay, well, that's what we got. I hope you like this. We're going to keep going and do a little bit more. I'll do some layout here before I post this and see what you guys think about it so far. Hang on just a minute. Okay, let's do some layout on it. Transformer, this will be mounted under the chassis. And, of course, we got to use a big hunking 5U4 in it. Look at there. 5U4 GB. I'm telling you, we're rolling here, aren't we? That guy will be right there. This will be under the chassis. The filter capacitor will be under the chassis. Here's the driver tube, 6SN7. Plate cap, blah, 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 all that stuff. We'll have our inputs and outputs over here on the left side. We'll have a on-off switch and a pilot light. And maybe a gain control, I don't know. Yeah, we need a gain control. But I like the gain control over here since this is just a power amplifier. But you know, you could use this for like a, let's put the volume control here. Like a pilot light, on-off switch, and a volume control. What do you think about that? Here on the front. Okay, and then just the input and the output here. Could put the output on this side. Input on this side, output on this side. I like everything flowing from left to right. Just like the old classic chassis, schematics that Collins Radio, Macintosh, Tektronix, all those wonderful companies build. Everything flows left to right. Well, I think it'd be better over here to the offset like that. Now, I want to ask you guys something. I have a couple of SE designs using a single 6SN7 driving an SET. This will be this is an 807. It'll be in triode mode, of course. You know, just nothing but the plate voltage and a bias. The bias is going to be cathode bias. I'm not going to build a bias supply into it. Cathode bias is actually good. I like cathode bias. I think that it sounds good. I got wires everywhere, don't I? And we're going to use the smaller of the two transformers because it's probably going to end up about 6 or 7 watts. But that layout here, I think I'll put the input and the output here on the same side. Input right here on the side and the output over here in the speaker terminals. It's only going to be 8 ohms. Or should the 8 ohms be on the back? I'm open for suggestions. I really am. And the last thing is, like I say, I've got a couple of SET designs. One that I've built and through a lot of tinkering, through what we call empirical design. That means just playing around with it until you get it to best. And then there's some on the internet that I've been impressed with. But if you've got something that you know, not just a wild experimental thing, but something that you have some real confidence in, that's a high-end performing SET amplifier with a single SN7 driving one tube, then maybe you can send me a link to it in a comment. Now, I get to select which one it is, so if you send me one that don't use it, don't be mad at me. Okay? Well, I don't know if I'll be able to wait. I might start mounting it tonight, but I'm going to go ahead and see if I can process this thing. I used to do it with a real simple program on Windows called Movie Maker, but Microsoft took that away from me, so now I have to use this thing called Clipchamp or some nonsense. I hate that thing. It's just, what a nuisance. I don't mean to start complaining here, but you know, they get a copy of my video before I do, and then I have to download it. I just don't like it, but anyway, not much I can do about it nowadays, right? So what do you think? Does this make sense? And not only that, we'll be able to experiment with 5U4, 5Y3, 5AR4, GZ34, whatever, solid state. I want to tell you something. The higher you can get the voltage, the plate voltage, without blowing the tube out of its socket, so to speak, the better it'll perform. And that's fact. They like higher voltage. You know, the 807 of what we've been told is actually a 6L6 GC with the plate cap up here, so you can run high as like 750 volts on it. The arcing within a tube at 450, 500 volts is not a threat with inside the electrodes of a 6L6. It's actually on the base. If you see this one's, I got to clean this one off, of course. Let's see if we can find a clean one. Yeah, this one's clean. On a 6L6, for example, you got the filament on 2 and 7. You got the filament right here, and you got the plate voltage right here. So you got that little barrier between it, but that's not much. So if you get the voltage up 550, 600 volts or something, and then you got audio on there and it starts oscillating at a kilohertz or something, it can arc from here, from the plate lead over to the filament lead to ground. And that's not good. So they moved the plate lead up to the cap so it can't arc the tube socket. That's basically the difference between an 807 and a 6L6 GC. Think about it. All right, well, let me see what I can do here, and we'll get started, and we'll see if we can build a really nice sounding SET amp, single channel. And I'll see if I can figure out how to play some music through it. And I'll also give you the web address for the man that custom lines these transformers after you see how well they perform. I think you'll be impressed. And the prices are quite reasonable. I'll tell you a quick story. I bought about, I don't know, weighed about 35, 40 pounds, and it was like $80 shipping from Poland to the United States. I thought, well, that's okay. Not going to be free. $80 is not free, but it's not much. But several years ago, I sent him a bunch of tubes. And I sent them in a FedEx box, so I thought it'd be cheaper in their box because, you know, it fits their, you know, it packs into their airplanes and everything really nice. And I sent it to him. We tracked it through Germany and everywhere else, and he finally got it. And when the FedEx man brought it to him and placed it in his hand, he wanted another $80 or $100. I don't know exactly what it was. I don't remember. And the good gentleman I sent it to says, well, no, I don't want to pay that. This is not right. This is not custom fees or anything. It's just it's just extortion. So you know what they did? They sent it back to me. That big package the package weighed like 5 pounds. There was more cardboard and packing in it than there were tubes. But that thing went all the way to Poland, and it ended up back on my front doorstep. It really did. And then a couple of years after that, I built an amplifier using the 6 B4Gs I sent him, and he saw the move, and he saw the posting on YouTube, and he said, David, those tubes just weren't ready to leave you yet. I just think it's really funny. And I still use them today. Isn't that amazing? I think that's fantastic story. Oh yeah, the last part of that story is not only did they want to extort another $80 to $100 from him, but they tried to charge me like $625 or $30 or $40, $600 and something dollars. I said, I don't think so. I guess probably that may be the secondary reason I got it back. If he had paid the fee there, I might not have gotten out of that $600. That's absolutely absurd. So before you send a package to Europe, you better know what it's going to cost. Doesn't cost much to get it here, but it costs a lot to get it there. Thanks for watching. Appreciate your comments, and stay safe.